The only difference between a floating structure and a landed structure is its foundation. Normal structure is supported either by a slab of concrete called a raft or by piles, and the building is supported by the friction from the earth and the piles, and occasionally from some end-bearing reaction. Floating structures, however, are different in that the foundation is not sitting on anything but just being supported by water. The structure will sink to a level where it displaces enough water equal to the weight of the structure. So it doesn't matter how big or how small the structure, it will float so long as it displaces enough water. It has what is called a righting moment. So when a floating structure is tilted, it uprights itself. Floating structure is independent of whatever soil conditions there is. It is immune to whatever rising sea level there is, It just floats. If the sea level rises, it just floats with it. Theoretically, there's no height limitation. It's 100% resilient against earthquake because it's not in contact with the seabed. So long as this structure is quite far away from the shore, right? A tsunami wave or energy will simply pass by and this thing will just float up and down. You can build the floating structure before you even determine the site, all right? So once you get a set of drawings, you can build a foundation for the floating structure in any country, anywhere in the world, and then tow it to the site. You don't demolish the structure. You can tow it away and repurpose the structure in another country, or within the same country, you tow it into a different planning zone and then repurpose it. You can move your asset, no matter how big. Just about anything it may be put on a floating structure. 1 kilometer long floating structure, a floating runway, which was tested and proven to work flawlessly in Tokyo a few years ago. Now, this is a floating nuclear power plant, which was recently commissioned by the Russians. This is in Monaco. They wanted to have a berth for cruise ships, and at the same time, they want to have a breakwater to protect all the boats in the bay. And this particular oil rig is built of concrete. And here's a comparison of the rig and the Petronas Tower. The rig is like 300 odd meters below water. So this is the Burj Khalifa, 828 meters, right? The Japanese, Shimizu, they are proposing, they've been going around trying to sell this idea of a 1,000 meter floating tower. It's so high, there's a temperature difference between the ground floor and top floor. In Norway, because of the fjords are extremely deep, so they can't build a bridge in the usual way with piers, right? So they came up with a solution to build these floating tunnels. And there are two ways. One is to suspend the tunnel from floats. The other solution is to have the float held down by tension cables. The float has got the buoyancy, so it tends to float up, you hold it down. Floating structures, we don't just simply design. We test it either by numerical modeling or by physical testing. And around the world, there are a lot of these testing facilities, including Singapore. Norway, they are testing this idea of a floating city that is 3 square kilometers large footprint. 3 square kilometers is bigger than Toa Payoh. Here in Singapore, we have all the necessary expertise to go into this field. The only problem is that the guys in the marine side are staying on the marine area, and the guys who are designing buildings on land don't talk to the people in the marine side. One of our aims is to try to bring the two groups together. Floating structures, you don't build it in a single monolithic piece. You build them in small pieces and you join them when they are afloat. That's why it can be of any size. So recently, Sembcorp Marine delivered 2 of such cranes. And this picture here depicts the size of the crane relative to Marina Bay Sands. Each of these cranes can lift 10,000 tons. So the entire top of the Marina Bay Sands, which is a steel structure, can be lifted up. I envisage Singapore to be somewhat like that. We have 700 square kilometers of sea space. We can use that bit there for industrial applications. This bit here for residential and commercial, because it's close to downtown. This in the east, you could use it for residential and logistics, for instance. And up there, you can zone it for use for agriculture and recreation. And then we have 3 corridors if you need to bring ships in, if you need to bring very heavy stuff into the land. We need to repurpose some of the land in that area. We could, for instance, vacate some of the land in the middle of the island, which is dedicated to military defense activities. Defense take up 19% of the land area in Singapore, more than housing. So you can shift some of those out to this area, you free up the land for housing or for other things. The mega port could be out here as floating ports. The shipyards which are here can be shifted out. And the other thing is the petrochemical plants which are sitting in this big island here. Once you rearrange all this, you free up the entire space here, and it could be repurposed for a lot more useful things. What Schumpeter is saying is that you need to occasionally, shake up your economies, your industries, in order to invigorate your economy. 3 industries that are under threat are port, hydrocarbon processing, shipbuilding. And if we accept the principle of creative destruction, we should be thinking of how to renew these industries. Shipping is now under threat, right, for a number of reasons. One is China's BRI, Belt Road Initiative, that will divert a lot of traffic away from the Straits of Malacca. Our neighbors are building their own ports. Indonesia, for instance, is going to build ports with capacities close to ours. So is Vietnam, so is Myanmar. Our shipping is dealing with 85% of it is in transit cargo. This port here occupies about 1% of the land area, and almost 70 to 80% of our sea space is reserved to allow ships to get to us. So there's an imbalance. We are not using our resources properly. So instead of this, we could have floating ports. And this one, for instance, is in the experimental stage in Netherlands. This one is being considered for the Gulf of Mexico. Hydrocarbons are also under threat. And the threats have to do with the fact that fossil fuels will not last forever. Renewables are, gaining market share. The economies around us have cheaper labor, cheaper land, and they can do things, this sort of things, much more cheaply. In Johor, they're building this massive petrochemical complex, which is 3 times the size of Jurong Island. And they got a strategic partner to work with them. A lot of the space in Jurong Island is being used to store oil. You see all these oil tanks here? That's a lot of space taken up just simply to store oil. And in a country like Singapore, where space is so critical, this kind of industries should be revisited and reconsidered again. This type of industry, you can only do it at one level. You can only build structures on the ground. But if you move into a 4IR industry, the 4th Industrial Revolution industry, you can have multiple industries, multiple story factories. On a GDP contribution per hectare of land, the 4IR industries is certainly more productive than this kind of industries. Can refineries and processing plants be floated? Yes. This is one example. And here's another example. The biggest floating structure in the world is the Shell Prelude, and it's processing out in the middle of the ocean. This is drilling for oil gas, and then they're processing it. So it's a totally floating structure. Another example of how the Japanese are dealing with fuel storage or storage of hydrocarbon products is having them afloat. And this is something which NUS is also doing. The NUS got a grant of $7 million to look into the possibility of having floating storage tanks. The area that is bounded in dotted lines is all shipyards. It was obviously the right choice because we have so much unemployment, and shipyards are good at absorbing unemployed people. History has shown that in all the previous shipyard centers around the world, all of them doesn't last more than 2 or 3 decades. They all succumb competition. India is coming up, Vietnam is coming up, right? Philippines is coming up. So these are competitive pressures that will impact on the viability of shipyards. Floating shipyards is a good solution because floating shipyards, you can build it, and if the environment gets too challenging, you can move it out to another country. They are already doing this in Korea. They are building ships, in this case a container ship for Maersk Line. They're building it in a floating dock. And here's one example of how it could look like. It could be just a floating platform in the form of a crucifix. A crucifix configuration gives you plenty of berth space relative to the size of the footprint. Those are not the only thing that can be floated up. Our cruise center at Marina Bay, that could be an entirely floating structure. Our desalination plant, high flux desalination plant, could be a floating plant. All our power stations could be floating. And if you're floating, then you don't have to worry about navigation channels to bring the fuel to the oil stations. You don't need jetties. Everything is done outside. Data centers generate an enormous amount of heat. And if you are floating, you have almost free cooling possibilities. Floating reservoirs is ideal for Singapore because Singapore receives 2.5 meters of rain, 2.3 to 2.5 meters of rain every year. Our consumption is half of that. If we can save the half that we now throw into the sea, we don't have to depend on Malaysia for water. So the solution that we're trying to work on is to build floating reservoirs that is connected to land. So the land is your catchment area. And when you fill your existing reservoirs, when your existing reservoir is full, you transfer that water into floating reservoirs. And on a dry spell, you bring the water back. Of course, you can float golf courses, recreation areas. You can even float prisons. We have 19% of our land area occupied by defense infrastructure. Half of that goes into the sea. We have plenty of land. The ideas that I'm proposing to you may sound outrageous, but you have to look at a timeline of not 1 year, 2 years, but 10 years, 20 years. And this sort of things could be reasonable.